The latest iteration of the highly influential Lancet Commission on Dementia Prevention, authored by numerous professors from around the world, led by University College London's psychiatry professor Gill Livingston, has for the third time ignored the hardest hitting evidence for homocysteine-lowering B vitamins, misrepresented the science on omega-3, and concluded that the evidence for unhealthy diet didn't meet their high bar for inclusion as a modifiable risk factor. Several eminent professors are up in arms and have written to the Lancet. In this podcast, I interview three of them: Joshua Miller, Professor of Nutritional Science at Rutgers University in the US, omega-3 expert, Professor William Harris from the Fatty Acid Research Institute, and Professor Richard Johnson from Colorado University's School of Medicine, to explore how the establishment continue to sideline nutrition. So our first Lancet omission that we're going to look at relates to omega-3. And to set the context for it, this is a 57-page Lancet Commission report. Most people are not going to get anywhere near the end. And tucked away on page 25 under a title that says Potential Risk Factors Considered with Insufficient Evidence to Include in the Model, we considered several of these factors, but on balance judged there was not enough consistent evidence to meet our high bar for inclusion as modifiable risk factors. These risk factors included too little sleep, an unhealthy diet, infections, and mental health conditions. So that's sort of the background. This is the section of things that they would not look at. And then when I read on, it says under the area of omega-3, and I'm quoting here, a French study, 1,279 people, average age 74, reported that increased concentrations of omega-3 index, and by the way, that's what we measure at Food for the Brain, it's the best test, developed by my next guest, Professor William Harris, concentrations of omega-3 index in plasma were associated with a decreased risk of dementia and less decline in medial temporal lobe volume. Now, those are the two hallmarks of dementia: brain shrinking and more symptoms in effect. It's a study, so it all looks really, really good. It's in 2020, but it's the only study referenced, okay? So now I read the letter to the editor of the Lancet by my next guest, Professor William Harris, and it says this, and I want to take it slowly so we understand the points. The report by Livingston et al. Cited only one observational study linking higher blood levels of omega-3 fatty acids with risk for dementia. That's the study we just saw, which concluded there was compelling evidence for a relationship between long-chain omega-3 fatty acid levels and lower risk for dementia. So we're all on the right page here. Essentially, the same conclusions were reached by several other similar studies between 2006 and 2024. There's Salavilla in 2023, Long in 2023, Schaefer in 2006, Samari in 2008, Aman in 2017, Mello van Lent 2021, and he in 2023, among others. I'm still on the letter to the Lancet. A 2019 review of observational and randomized clinical trials concluded that omega-3 fatty acids were, quote, safe and well tolerated, representing, quote, a valuable and biologically plausible tool in the management of neurodegenerative diseases in their early stages, end of quote. The vast majority of adults in the Western world have suboptimal blood omega-3 fatty acid levels. There's a quote for that. Correcting this deficit would not only reduce risk for dementia, but also cardiovascular and other inflammatory related diseases. Importantly, the discovery that the cognitive benefits of omega-3s and homocysteine lowering B vitamins are codependent and there are some trials that relate to that, highlights the fact that some neutral omega-3 studies may have been a consequence of this nutrient interplay, i.e. that the omega-3s work in individuals with low, healthy, but not high homocysteine levels. You need enough B vitamins for the omegas to work. Final point, increased consumption of marine omega-3 fatty acids is safe, simple, cheap, and effective tool in the fight to forestall the development of Alzheimer's dementia. Why were these nutrients and the studies supporting their efficacy ignored in the Lancet Commission report? This is signed by Professor William Harris, Associate Professor Thomas Wood, Dr. Simon Dahl, all members of our Alzheimer's prevention expert group. So, Bill, William, this is your letter. That's the Lancet Commission. How could they only refer to one study? I've been seeing studies as headlines in the newspapers over the last 2-3 years.
Oh, I know. And what a great letter. Read slowly back. And I can't take full credit for that. That was 3 people signed it, 3 people worked on it. It was a good letter. Excuse me. How they ignored it, I have no idea. Why they ignored it, I have no idea. One of the other, what they call modifiable risk factors is air pollution. I mean, how are you going to modify that? First of all, as an individual person, what you can do about that? Wear a mask all the time, I suppose. Wear a gas mask. Do they have any randomized trials with air pollution to show that people who are exposed to higher level versus not in a randomized trial got less dementia? No, they don't. It's observational data. That's what we have, and more with the omega-3s. But they seem to have ignored omega-3 observational data and took the stuff with LDL cholesterol, vision lost, hearing lost. All those things are observational. They're not randomized trials where they're treating hearing loss. You know what I'm saying? So it's a puzzle to me why something is so obvious as omega-3, which is a long history of being at least a potential modifier of risk for Alzheimer's disease, dementia, cognitive loss. Why that got ignored is completely beyond me.
So what you're saying is there's a set of rules they've applied to other risk factors who've made it through the gate.
Right.
And for some reason, they're not applying the same rules to omega-3.
Exactly. Right.
And is it difficult to do a literature search and find these major studies, which, by the way, I believe one of the latest ones was from the UK Biobank. This is a UK-based science report. So the UK Biobank data, I saw it. It was front page of several newspapers. Is it difficult to find these studies?
It is. Good question. No, it is not difficult. It is not difficult at all. If you find all these other studies, it's a simple PubMed search. And it's just a matter of putting in the terms omega-3 and dementia and hitting go, and you get, maybe 500 hits. Why they don't, I mean, again, I just can't believe that they cited only one paper, for which there's many more papers they could have cited. One can only get into the minds of the people who wrote that report and ask them why they didn't.
Now, I remember back in 2003, a study by Professor Martha Morris, who was part of our science group as well, which said that participants who consumed fish once a week or more had 60% less risk of Alzheimer's disease, published in the Journal of the American Medical Association Neurology. That was what alerted me. So we've got more than 20 years of relatively consistent data, all pointing in the same direction.
Now that one, I could criticize that one because it's fish. It's not omega-3. And there could be 50 different nutrients in fish that are contributing, zinc, selenium, things like that.
Yeah.
It's the ones where they actually measure blood levels of omega-3.
Yeah. So with that
link. Yeah. Link those to outcomes. That's important.
And it was your research that led to the development of what is now becoming widely considered the best blood test for omega-3, which is the omega-3 index, which is the percentage of EPA and DHA in the membranes of red blood cells, in essence.
Right.
So we've got a criterion. The point is that when you have a risk factor, There are a few things you want to know. Can you actually identify those who are at risk? And the answer is yes, there is a test. Then the next question is, if you are at risk, low in omega-3, what degree of improvement would occur if you took a changing action, which in this case, I will ask you about in just a second. But the point is, it's an easy action to take,
Right.
whether it's eating fish or whether it's taking a supplement. And then the other half of that, which is where I'd like to start, is how many people have this risk factor. So how many people have a level of omega-3 index that is low enough to actually incur increased risk of dementia later in life?
Well, it's a sliding scale, of course, like a lot of things in biology. The higher the level, the lower the risk. So people at kind of mid-range levels are lower risk than people at the lowest levels, but probably at the lowest levels, we're still talking about an omega-3 index of, say, 4% or below, and that is maybe 60, 70% of the Western population.
And what?
Huge group.
Yeah, a huge group. So, over half of the population.
Oh, yeah.
And what level of omega-3 index can you say you couldn't really see additional risk?
Additional protection, or
yeah, you've achieved the most protection you're likely to.
Oh, like what's an optimal level for?
Exactly.
Yeah, we like about 8% and above, 8% omega-3 index, so twice as high as this 4%.
All right, so we have something terribly clear. Well, I mean, the whole cholesterol section was extremely muddy, not clear. So we have something very clear. You've got to measure. If you're at 4%, you're at risk. If you're at 8%, you're not at risk. You've optimized. So then I know this is a sort of very broad question, but it's worth having a sort of yardstick on. If somebody was at 4%, to what extent, if they could increase their level to 8%, would it reduce their risk of dementia? What sort of?
I think if we just look at this, and to the credit of the Lancet report, there are many things that contribute to your risk for dementia. It's not all about omega-3. It's not all about B vitamins. And so correcting this one risk factor reduces your risk by about 20%. I think from the highest to lowest, roughly 20% down.
Okay, and the essential calculation that they've used to come up with 7% for cholesterol or this much for air pollution is to do with the essence of it, is if half the population were low in omega-3, and if you corrected that, you would have a 20% benefit. Then you would say that the population risk is half of that, because only half of the population have a problem. So it's that sort of zone. So this isn't, the exact maths, but that's basically how it's done. So somewhere around 10%, which, by the way, would put omega-3, right at the top of that long list of things that we can change.
Yeah, I completely agree. And it's very easy to change, very safe to change. Some of the things in that list are virtually beyond your control. And back to air pollution. Okay. Yeah. There's almost nothing you can do about it.
And the other thing that really strikes me is when you do look at air pollution or, whatever, hearing loss, basically what they do is they take a number of studies, it may be 6, it may be 10, whatever there is, and then, work out the maths on what's the average reduction of risk. Now, that sort of analysis cannot be done on one study. You need, a few.
Yeah.
It would have been easy to do.
Right. A meta-analysis.
And if that had been done, it wouldn't have been stuck. Omega-3 is in the insufficient evidence section with the excuse that they only looked at one study, which was very beneficial.
Yeah, right. That was a good study. Right.
Yeah. So there's no real reason why the Lancet Commission omitted a very easy, very safe risk factor that affects more than half the population and is very easy to change. Is that basically it?
There's no reason that I know of. There's no logical reason to avoid that, to skip that one.
And finally, one of the things that concerns me is sometimes, when looking at drug studies, we are always looking for that randomized placebo-controlled trial model. But when looking at diet, it's sort of impossible to do randomized placebo-controlled diets because people eat something. Do you think a different methodology should be applied to nutrients and dietary risk factors than to drugs?
Well, I mean, it's an honest question to say if I give 1,000 people a placebo, a dummy pill, and I give 1,000 people a omega-3 pill and raise their omega-3 index from 5% to 8% by doing so, do I reduce risk for dementia? I mean, that's a perfectly good research strategy, and that's kind of a drug strategy. I mean, that's one thing about omega-3s that's fairly easy to do because the background intake is so low of omega-3s, where other nutrients, maybe even B vitamins might be an example where it's kind of tough because there's so many foods that contain fortified B vitamins. Not true with omega-3. So it's a tough, in nutrition, it's very tough to do randomized trials in general because as you point out, everybody eats all these nutrients. It's not like in a placebo and a drug trial where the level in the blood of the placebo is zero or the drug is zero. Not true in nutrition research.
So do you think from the wealth of the evidence that exists in omega-3, it is clear, there is indisputable evidence that increasing omega-3 when you are deficient reduces your risk for dementia in the future?
Yeah, I think I could stand on that. I believe that's true. I think it's certainly worthy of being in the Lancet report as one of the top interventions that people can do that are actionable. And it's again a complete puzzle why it was ignored.
Well, thank you, Professor Bill Harris, for your superb research, and thank you for writing this letter. We will not let this go unattended to. Now, the next omission we're going to look at relates to B vitamins and homocysteine. These didn't even get a mention. I mean, like not a single mention. And unlike omega-3, we did actually send the Lancet Commission researchers every single paper on 2 separate occasions. We know they got the research. So let me read the letter written by a number of eminent experts in relation to B vitamins and homocysteine. The Lancet Commission's latest update on dementia is timely and important. We wish to point out a glaring omission from the report. Homocysteine is a sulfur amino acid product of methionine metabolism. It predominantly reflects the status of 3 B vitamins, folate and vitamins B12 and B6. A consensus statement of international experts concluded that a raised blood level of homocysteine, hyperhomocysteinemia, is a modifiable risk factor for the development of cognitive decline and dementia, including Alzheimer's disease in older persons. The relative risk of dementia for moderately raised homocysteine ranges from 1.15 to 2.5, and between 4 and 31% of dementia might be caused by raised homocysteine. Homocysteine-lowering treatment with inexpensive and safe B vitamins markedly slows brain shrinkage and cognitive decline in elderly individuals with cognitive impairment. And those are the 2 signs of dementia. Notably, the effect of homocysteine on dementia risk is strongest when omega-3 status is inadequate, suggesting a synergistic effect. Unfortunately, despite such robust scientific evidence, determination of homocysteine levels in individuals presenting with memory impairment is not routinely undertaken. Prevalence of hyperhomocysteinemia in older American adults is greater than 10%. Health economic analysis shows that homocysteine screening followed by treatment with B vitamins would be a highly cost-effective in older adults presenting with cognitive impairment. It is therefore disappointing that the Lancet Commission fails to recognize hyperhomocysteinemia as an important modifiable risk factor for age-related cognitive decline and dementia. We look forward to the Commission correcting this omission. Now, this letter is authored by Professor Joshua Miller, chair of the Department of Nutritional Science at Rutgers University, and co-signed by Professor David Smith from Oxford University, Dr. Andrew McCadden from Wrexham University, Professor Jintai Yu from Fudan University in Shanghai, who is vice director of the Institute of Neurology and one of China's leading dementia prevention experts, and Dr. Babak Hushmand from the Aging Research Center at the Karolinska Institute in Stockholm, Sweden. These are heavyweights in the world of nutritional science, and we are honored to be joined now by the lead author, Professor Joshua Miller. Can I call you Josh?
Yes, that's fine. Thank you.
Thank you very much for coming on the podcast. So why did you and your colleagues feel the need to challenge the Lancet Commission?
Well, I believe that the evidence that has been published over the last 20 years or more has accumulated to the point where we can definitively say that elevated homocysteine is associated with and predictive of age-related cognitive decline and the risk of dementia and Alzheimer's disease. And we have a means of lowering it. And while the evidence is not as extant, there is pretty good evidence that lowering homocysteine will slow things down, at least slow things down, if not prevent. And the fact that the Lancet Commission has now in its third iteration of looking at dementia has dismissed B vitamins and homocysteine is just an omission that we couldn't ignore, and we needed to write this letter.
We've actually been in touch with a number of the co-authors of the Lancet Commission, and despite the fact that quite a few of us had sent all the studies relevant for homocysteine to the lead author, Professor Gill Livingston, it does not seem that she has presented them to the group as such. So she had the studies, didn't appear to have shared them with the group. So it is a pretty major omission. Now, in the Lancet report, it comes up with a figure for a particular risk factor. For example, high cholesterol, 7%, visual loss, 2%. This percentage is defined as the percentage reduction in cases of dementia if this risk factor is eliminated. And as I understand it, it's a function of two things. One is how many people have this risk, such as visual loss, and if you correct it, for example, cataract surgery, to what extent does that improve the situation? So my first question to you is, how many people have a level of homocysteine above 10 or 11 micromole per liter, which appears to be the danger zone? And also, is this age or sex dependent?
Yeah, so that number is a little hard to pin down, but there's some good evidence in the United States that people over the age of 60, that the number that exceeds some cutoff for homocysteine, whether it's 10 or 11 or 12 or 13, somewhere in that range, is definitely over 10%. And it is definitely something that's seen in older people. Homocysteine tends to rise as we age. So it's less prevalent in younger age groups.
Now, I've noticed in data from China reports, quoting one, that the mean homocysteine level in adult males less than 30 years of age and greater than 60 years were higher than the upper limit of normal, which was 15 micromole. And then recently, I was shared data from Norway, and this was people aged 20 to 45. And this data, part of an MSc student's research, indicated that more than 30% of women and more than 50% of men in the age group have homocysteine above 11. So, these are getting to be quite big numbers. And then just a couple of weeks ago, there's a study out from Korea which measured homocysteine in over 220,000 men, and 61% had a level above 10.
So let me add a little bit of historical context to that. So in the United States, before we had folic acid fortification, which occurred in the mid to late 1990s, the reference range for homocysteine in just sort of the general population was around 4 to above 20. And then after fortification, that upper range of that reference range has come down dramatically. And now the reference range is about 4 to 10, 4 to 11. And so I suspect, particularly in China, definitely, also in Europe, that where there's no mandatory folic acid fortification, that the reference ranges in the general population are similar to what they were in the United States before fortification. So I think that's explaining the disparity among the different countries. And it also points to the, based on the data that's showing that high homocysteine is associated with vascular disease and dementia and Alzheimer's, that there may be a lot of good that can be done around the world by lowering homocysteine levels.
So at the moment, we're talking about the level that is of concern. And I know our experts at Food for the Brain wanted us to say, treat anyone with a homocysteine score above 10. And then if we push a little bit further, you will have seen the recent paper in July by Dr. Annick van Soest. And in this paper, she used high as anything above 8 micromole per liter. So started to see an association of more risk above 8. So it's sort of interesting. And I mean, this isn't necessarily a science question, but what level would you be happy with? I'm 66. You're younger. Would you be happy with a level of 10 or 9 or 8? What would you shoot for, maybe in the more optimal zone?
Yeah, so what we do know is that within the range of 4 to 10, you can still, in many people, drive homocysteine down further. But it's very difficult to know if that is actually doing you any additional good. I personally, when I'm doing research, we use cutoffs like 12 or 13 to identify people with hyperhomocysteinemia. So, pinpointing this cutoff would require a lot of sort of dedicated research to try and figure that out, and looking for inflection points between homocysteine and whatever your outcome is. And so I feel most comfortable with 12 or 13.
Okay.
Yep.
So that speaks to the number of people who may have a raised level, more likely later in life, over 60, 65, 70, and so on. Is it more common in men or women, or it doesn't really matter?
Oh, so that's an interesting story also. Throughout adulthood, up until menopause, women tend to have lower homocysteine levels than men. After menopause, homocysteine levels rise in women, which indicates that there is a hormonal influence on homocysteine metabolism. That disparity between men and women disappears after menopause.
Okay, and the second half to this question, because these are the two figures needed to work out this population attributable risk, is if you do have a raised homocysteine, whether it be above 10, 11, 12, 13, to what extent does lowering it reduce dementia risk?
All right, so that's a more difficult question. So I want to nuance it a little, the answer a little bit. First thing I want to do is compare studies that are like nutritional supplements particularly of vitamins and minerals that people get in their diet anyway, versus a drug. So drug studies have the benefit of starting people with zero drug, right? And you either get the drug or you get a placebo. And then, so your comparison between your treatment group and your placebo group is not confounded like it is in supplement studies, where if you're going to give, say, B vitamins like B12 and folate, but the people in your study, some start with higher levels of B12 and some start with lower, some higher levels of folate, some lower, that it takes a lot more people to be in your study to be able to see the effects, because you're basically confounded by a person's status. So that's part of the nuance, and what you'll see in the literature is that there are studies that have tried to reduce the risk, either of slowing cognitive decline or reducing the risk of Alzheimer's or other dementias, but you'll find that many of them were not successful. And so the problem that we have is that those studies are seen, and they're seen as being negative, and they suggest to us that maybe the B vitamins and lowering homocysteine won't work. But if we take the example of what's called the VitaCog study, which is I think one of the lead investigators was David Smith, also an author on the letter we've just written to Lancet. That study was done in a way that actually kind of minimized this issue that I'm talking about. And first of all, they were able to pick people who are have mild cognitive impairment. So people in their 70s, and they have started to decline in their cognitive function, but they haven't gone so far that have outright dementia, but they're not completely healthy. And in that study, they were able to show that B vitamins slowed down the loss of the brain atrophy that was occurring in these people, as well as maintain cognitive function. But they also found that it was those with the high homocysteine that it was most beneficial. So that is the kind of study where the right people were studied and the right things were looked at. And that is where a lot of emphasis should be placed on how much risk reduction we could see. Now, that study didn't go to ask how many people didn't get dementia or how many people did get dementia, but you can see the maintenance of the cognitive function in that study and the slowing down of the neurodegeneration. So I'm not sure I'm going to actually answer your question with a number how many people might be prevented based on that, but I think that gives you a sense of what could be done.
And I think in that study, 30% ended the trial with a clinical dementia rating of 0.
Yes.
In other words, not clinically, having a problem. So, which is quite extraordinary. But in the Lancet Commission, they're referring to these population attributable risks. So, for example, for smoking, it's 2%. So, are there studies that have looked at the population attributable risk for homocysteine?
Yes. So I would refer to a meta-analysis. I think it was from 2014. First author is, I think it's pronounced Beydoun. And in that meta-analysis, the population attributable risk, I believe, came out to be around 20% for elevated homocysteine. And that meta-analysis looked at both cross-sectional and cohort studies, as well as several prospective studies. Not randomized controlled trials, but the PAR from that study, the population attributable risk, was around 20%.
And I believe in the consensus paper on homocysteine, which you quote in your letter, there is a range of between 4 and 31%.
That's correct.
Yeah. So just to understand this, if half the population, that is an over-exaggeration, have raised homocysteine, and if according to the Beidoun paper, that's a researcher from the National Institute of Health, the population attributable risk is 22%.
22, yeah, okay.
It'd be half it, because half of the people don't have raised homocysteine, half of the people do, and for those who do, they would reduce their risk by 22%. Is that how it works in rough terms? So like a 10% overall reduction, because half of people won't benefit because they don't need to, because they don't have raised homocysteine.
Right. I think that's a pretty good interpretation, yes.
Yeah. So at the very least, lowering homocysteine could have twice the impact of stopping smoking. And by the way, in the UK, 8% of people smoke over 65. So it's not a very, very large percentage of the population. Mm-hmm. And, you know, if that were the case, then it might cut dementia risk by, you know, maybe a quarter, something like that. I mean, it's going to be in something like that zone.
So here's where I think we need to have a little bit of nuance, because that number could be a bit of an overestimate. And the reason I say that is that none of these risk factors should be taken in isolation. So we know that the homocysteine lowering effect can be influenced by other factors. So for instance, you have omega-3 fatty acids can interact with homocysteine, and the effect can be stronger or less depending on your omega-3 fatty acid status. Other factors come into play, like I want to say non-steroidal anti-inflammatories or lipid-lowering drugs. So there are interactions that are going on that the homocysteine effect has to be considered in combination with some other factors. So if you just target homocysteine with B vitamins, perhaps the prevention that you might get from that might be a bit less than 22% or whatever number we're talking about. But I still think it's relatively significant once you take that into account.
Yeah, it's, you know, it certainly seems to, if you like, compete extremely well with things like hearing loss, visual loss, smoking, etc., and yet it is ignored. And that study I referred to earlier, the July study of Van Soest, is quite interesting because what Professor Aniek did in that study was to measure homocysteine, omega-3, and vitamin D. And the participants were allocated to be either high or low. So low omega-3, low vitamin D. High homocysteine is bad news. So, you know, good or bad. And what was interesting is that those people who were poor in homocysteine, in other words, high, lacking B vitamins, low in omega-3 and low in vitamin D, had quadruple the risk. That was quite interesting to see how we could combine risk factors. What was your take on that study? I know it's small, but it's starting to work towards taking other factors into account.
Yeah, I think that study is extremely important because, you know, as scientists, we tend to be reductionists. We want a single thing to be the cause, right, that we can then target. And I would suggest that medical doctors are even more in that mode. You know, they want to give a pill and be done, or they want to do a surgery and be done. And what we're finding out, particularly with nutritionally related outcomes, that it has to be much more holistic, that you have to be thinking in terms of multiple factors. And this is what's actually very good about the Lancet Commission report, is that that's what they're trying to get at, that there's multiple things that you can do, multiple lifestyle changes that you can make that could reduce your risk of getting, you know, dementia. And I do want to add in one other point, and that is when you look at some of the other factors. Let's take smoking, for instance. There's been no study, a randomized control trial of smoking and its influence on getting Alzheimer's disease, for instance. That would be a completely unethical trial. And the thing about that is we still say, the commission still says that smoking is important in this regard, even though the gold standard studies have not been done on that because you can't do them. And yet they do not consider B vitamins and homocysteine, where there is actually randomized controlled trials, at least the VitaCog trial, that clearly shows a potential benefit. So how do you keep smoking in as a risk factor and not include B vitamins and homocysteine? It's really a strange thing to me.
And when we were talking about the Van Zoy study, where she looked at homocysteine, omega-3, and vitamin D, none of these nutrients were considered in the Lancet Commission. I mean, omega-3 was mentioned in relation to one study. We know there are many. Is this a major oversight of the Lancet Commission to ignore all these three nutrients?
Yeah, I think so. I think definitely. If you look back into the two earlier iterations, I think 2017 and 2020 of the Lancet Commission, I think early on there was like a brief mention of B vitamins and then a dismissal of it because they cited maybe one study that was didn't show an effect or something. I forget exactly what it showed. But the problem is that when a mistake like that, an omission like that is made early on in this commission, then when they come out with later versions, they don't consider things that they've already dismissed. They're only considering new data that has come out. And I think that's a mistake on their part. They need, and particularly as far as nutrition and micronutrients are concerned, they really need to go back and start from scratch and start considering them.
Various members of our group have spoken to the lead author, Professor Gill Livingston, and she has consistently asserted, A, that high homocysteine is extremely rare, and B, there is no evidence of any benefit from homocysteine lowering B vitamins. Is this wrong?
Yeah, yes, it's wrong. And I think we have the data, there's publications, peer-reviewed publications that clearly show that that's an incorrect view of the situation.
And do you have any view on why there is this resistance to objectively consider the evidence in relation to nutrients?
You know what? I don't know. I can't get into the minds of the commission. I know that from the pharmaceutical company point of view, you can't make a lot of money on B vitamin supplements. And I think an interesting comparison that I've heard somebody make is that if the effect that we've seen in at least one or more studies of lowering homocysteine with B vitamins were seen with a new drug that had been developed, with billions of dollars of effort over many years, that they would have been touting that drug to the high heavens and pushing for the FDA to approve it.
Professor Josh Miller, thank you for sharing your wisdom with us, and thank you for your excellent letter to the Lancet. We hope that it will make a difference. Thank you.
Thank you.
Now, the third letter we are going to home in on and speak to the lead author, Professor Richard Johnston from the University of Colorado, together with neurologist Dr. David Perlmutter and endocrinology Professor Robert Lustig. concerns fructose and sugar metabolism. But before we get into the actual details of their submission to the Lancet, it's worth explaining a bit more about the fundamental chart or infographic in this report, which, quite frankly, is all many GPs and health policy makers will pay attention to. And this is the one that assigns a percentage of prevention power to a number of factors, totaling 45%. In other words, 45% of dementia is preventable, and this is what to target. Now, this includes low education and early life, air pollution, traumatic brain injury. Now, none of these are easy to change, especially in a person with cognitive decline. Then we have smoking, excessive alcohol, physical inactivity, visual loss, and a new one, hearing loss. Now, these you can change. Studies show cataract surgery and hearing aids help reduce risk. So the more you can hear and see, the more the brain is stimulated. The rest are high LDL cholesterol, depression, diabetes, hypertension, blood pressure, obesity. Now, conventional medicine treats these with medication to lower cholesterol, to treat depression, to control diabetes, to lower high blood pressure, and even promote weight loss with the GLP-1 agonist drugs such as Ozempic. Now, the diabetes section is all about whether or not giving this or that drug helps lower dementia risk, but not a mention of a low sugar or low carb diet, despite the fact that these interventions do reverse type 2 diabetes. An unhealthy diet is not included in the risk factors for dementia. The report does discuss the evidence relating to diet and concludes eating a diet high in fruit and vegetables, low in ultra-processed foods is good for many health conditions and affects the dementia risk factors of obesity, diabetes, and hypertension, but insufficient evidence exists to say that this diet is directly useful for dementia prevention. So that's the background. Now, I want to read the letter as submitted to the Lancet by our guest today, Professor Richard Johnson and colleagues. Here it goes. The authors present a comprehensive epidemiological-based review of risk factors for Alzheimer's disease. However, epidemiology can be misleading if the underlying pathophysiology is not considered. For example, the observation that obesity, gout, and diabetes are risk factors for Alzheimer's disease at midlife, but not at time of diagnosis, is likely due to the marked weight loss that commonly presages diagnosis of dementia, similar to that seen in subjects with end-stage renal disease. Diet, which drives these conditions, follows these same confounding rules. Recent studies argue that fructose generated and metabolized in the brain may account for the majority of cases of Alzheimer's disease. Fructose, fruit sugar, is a risk factor that can explain development of Alzheimer's disease from inception to end stage. Endogenous production inside the body of fructose is largely driven by diet, sugar, refined carbohydrates, ultra-processed foods, salt, red meats, and alcohol. Hyperglycemia, high blood sugar, also increases brain fructose production. Humans with Alzheimer's disease show 5-fold higher intracerebral fructose levels, that's in the brain, as well as higher metabolites of the polyol pathway, which generates fructose, than age-matched controls. Fructose metabolism stimulates foraging as a survival response, but when chronically activated in animals, causes insulin resistance in the central nervous system, the brain. Mitochondrial dysfunction, those are the energy factors, ATP depletion, that's what we make energy from, neuronal loss, loss of brain cells, and amyloid plaque and tau protein deposition, similar to Alzheimer's disease. The mechanism is mediated by fructokinase and resultant uric acid inhibition of mitochondria in microglia. Those are the cells that feed the neurons, the brain cells in the brain. A finding supported by animal data, metabolomics, and Mendelian studies. An essential strategy for preventing Alzheimer's disease is to follow a healthy diet, low in added sugars and refined carbohydrates. So that's the letter. It's authored or co-authored with Dr. Robert Lustig and David Perlmutter, who you may know are author of many best-selling books on diet and the brain. And the lead author joins me now. Welcome, Professor Richard Johnson, to my podcast. Can I call you Rick?
Yes, Patrick, and may I call you Patrick?
Certainly. So there's quite a lot, in the letter to unpick. But just before we get to it, what's your overall take on really what is one of the most influential documents, the third issue of the Lancet Commission, in effect, totally ignoring diet?
Well, I feel it's a disaster for the reader and for science to not acknowledge diet as an important player in metabolic conditions, including dementia. I do think that there are many wonderful things about that review, and it's nice to have an epidemiologic review like that. But I do believe that the omission of diet and homocysteine and omega-3 and sugar, I think that this is a disservice, and that's why we wrote the letter, is because we want to alert the readers to the fact that there's a major mechanism that drives Alzheimer's disease that is reversible, potentially preventable, potentially reversible early, and it relates to diet. And so, the evidence is frankly overwhelming.
So let's get into that mechanism. And also, from my point of view, when this report focuses on high cholesterol, on diabetes, on high blood pressure, on obesity, but doesn't really ask the question as to what's driving those. Maybe this mechanism is not just about dementia, but it's also about all these other conditions that statistically increase the risk for dementia. So what is this fundamental underlying mechanism that you're getting to in your letter that relates to our diet and that then drives all these diseases, including Alzheimer's disease? How does this work?
Well, thank you, Patrick. Well, for the last 20, 30 years, I've been studying the cause of obesity. And we had identified that a particular nutrient, fructose, which is a sugar, and it's in table sugar, like table sugar is half fructose and half glucose, and it's called sucrose. It's also in sweeteners like high fructose corn syrup. And these are called added sugars, and fructose is is a big component of these added sugars. And currently, people are eating about 15% of their diet is added sugars in the U.S. And we discovered, along with others, that fructose seems to be a unique nutrient that could cause obesity and diabetes. And when you give fructose to animals, they start gaining fat. They become insulin resistant. Their blood pressure goes up. They develop features that we call metabolic syndrome, and over time they can develop high blood pressure, diabetes, fatty liver, kidney disease, and even they have cognitive problems, and they can have trouble, like laboratory mice fed sugar have trouble getting through a maze, for example. And so it was really interesting why this particular nutrient could do that. And what we discovered was that nutrient activates a pathway that is actually meant to be a survival pathway, but when it's chronically activated, turns out to be bad. And so what it happens is when an animal eats a lot of fructose, they actually will drop the energy in their body. And normally we think of energy, as energy is what we use to do everything we want to do, to think and everything, and it's driven by a particular substance called ATP. That ATP is made by mitochondria. And these little mitochondria are present in our liver and all our brain and everywhere, and they make the ATP that helps those cells function. Normally, the way it was thought that people get obese is you eat so much food, you fill up your cells with energy, the ATP, and then what's left over gets stored as fat, as a form of stored energy. So fat becomes stored energy. And, and then if you don't have any food around, you can break down the fat to generate energy. And so basically there's active energy, which is our ATP, and stored energy, which is our fat. And it was thought that you become obese by kind of filling up the tank, and then the extra energy gets put into fat. But what we discovered was that the way it actually works is that you drop the energy in the cell, the active energy, the ATP. And the way fructose does that is it stuns those little mitochondria, those little energy factories that make ATP. So it works on the energy factories to make them produce less. And when the ATP levels fall in the cell, it's like the gas light going on in your car, and it kind of says, hey, we're at risk for going into a low energy state. We're running out of energy. We're going to starve. We need to eat. And so it activates the whole system to try to store fat and to increase energy intake. And we discovered that this was a basic mechanism, and that fructose is the only nutrient that actually drops ATP in the cell other than alcohol. And alcohol actually does it in part through this pathway, believe it or not. But what happens is when you eat fructose, you drop that ATP, you stun the mitochondria, and you develop these conditions like insulin resistance, high blood pressure, all these different things. And
So
yeah, go ahead.
just going back to animals. So it's a bit like if you eat fructose, which in this case is fruit, which of course they're going to do seasonally. What you're saying is to have less energy and a greater desire to eat more.
That's right.
So why would animals do this? Why would animals do this?
Yeah. So what happens is animals don't like to starve. They do not want to run out of food. And the trouble is they're normally regulating their weight. And when there's food around, why would they want to get fat? Because, there's plenty of food around. But if they know that, for example, that winter is coming, and we can talk about how this signaling occurs if you like, but when they want to know that winter is coming, they have to store fat even when there's, when they don't actually need it at that time. They don't need to be fat in August because there's still food all around, but they have to prepare for when there's no food around. And the way they do that, the way a lot of animals do it, like bears, is during the fall, the fruit starts to ripen and the sugar content goes up. And instead of eating just a few fruit, like we do, they eat thousands of grapes in a 24-hour period. They can eat 10,000 berries. And what happens is they get a large amount of fructose. That drops the ATP in their cell, and that stimulates a whole bunch of things. It stimulates hunger. It stimulates thirst. It stimulates foraging, where they have to, in order to forage, they actually have to go out into and look for food. And foraging it requires a whole set of behaviors. When you forage, you want to be able to move fast and get around, but you also want to not spend much time in any one spot. You have to be able to look around, find the food. You can't perseverate. You can't think very long about anything. You have to be impulsive. You have to be brave. You have to go into areas that are dangerous. And it turns out to do that, fructose inhibits certain regions of the brain. So when you eat fructose, it will inhibit blood flow to the cortex so that you actually reduce your self-control. It decreases the blood flow to a thing called the hippocampus, which is involved in memory. And because it doesn't want you to remember the lion that was in that area too vividly, because you got to go in there to find the food. And so it affects different regions of the brain, and you can show that in humans. If you give fructose, that you suddenly can see food more clearly. You want to eat it more, you can pick out a cake more easily. It lights up that part of the visual cortex, and it decreases areas of self-control. And the way it does it is by blocking inducing low-grade insulin resistance to those regions of the brain. So it reduces the glucose uptake, and it reduces the function of the mitochondria. It causes low-grade inflammation. And it's all these things have now been discovered to occur in Alzheimer's. So for a long time, they thought that Alzheimer's was a disease that was mainly due to amyloid plaque and tau protein. And everyone was developing drugs to block that, but then the success hasn't been that great. So people are looking earlier at what happens early in Alzheimer's, and they're finding that people with Alzheimer's have mitochondrial problems, they have low ATP, they have lactate buildup, they have inflammation, they have insulin resistance. And guess what? That is exactly what fructose does. That's exactly what fructose does. And so interestingly, when we were studying this, we realized that, this was to stimulate foraging, but when you do it chronically, it causes neuronal loss. And if you give sugar to animals long-term, they actually develop tau protein and amyloid and loss of neurons. And, so the whole story fits. And the risk factors for Alzheimer's include sugar intake, high carb intake, diabetes, insulin resistance, obesity, and these are the same conditions that are all linked with fructose.
And presumably this also pushes up cholesterol and blood pressure.
A little bit. It pushes up LDL a little bit. It reduces HDL. But the lipid pathways are a little bit less strong than some of these others. The insulin resistance pathway, for example, is very, very powerful. But our biggest breakthrough in this was the discovery that the body makes fructose as well. And the body makes fructose from carbs. And when you eat a lot of high glycemic carbs like pancakes and rice and potatoes, your brain will start making fructose. And this was actually shown at Yale by a brilliant scientist named Sherwin, who showed it in humans that when you raise blood glucose, you start making fructose in the brain. And we know that when fructose is locally produced, that it causes all these problems associated with Alzheimer's. And so then a big paper came out that showed that people with Alzheimer's have 6-fold higher fructose levels. They have all the enzymes involved. They're activated. You can block the enzymes in animal models and improve things. I mean, it's pretty strong. The evidence is like kind of overwhelming, to be honest. And so, there's even this wandering response that patients with Alzheimer's have, which is probably this foraging response, that's carried over. So it's pretty strong. I think that the bottom line is you can really benefit by reducing your carb intake and reducing your sugar intake.
So what you're really saying is that this massive cultural change towards high sugar, high carbs, fructose, which is part of sucrose, fructose, it's part of corn syrup and so on, has ironically created a deficit of energy in the brain and a sort of loss, brain fog, so to speak, a loss of memory, possibly a kind of hyperactive foraging process.
Yes.
And of course, what we see in people with dementia and Alzheimer's is that they crave sugar, they crave
Yes,
carbohydrates.
absolutely.
So the more they eat, the more they crave, the more their memory goes down. All the markers, amyloid, tau, etc., go up. It's a fundamental underlying mechanism, which is
Right.
not only tying in all the risk factors for Alzheimer's disease, but also for these other conditions like diabetes and obesity, which we know are related.
And
And
other ones
yeah,
too, Patrick,
yeah.
like traumatic brain injury.
Mm-hmm,
A group in Los Angeles showed that when you get traumatic brain injury, that results in some reduction in blood flow in that area, and
mm-hmm,
that stimulates local production of fructose.
Mm.
And that fructose drives the disease. And guess what? One of the things that can block fructose, omega-3.
mm-hmm,
And you give omega-3, you can block some of this pathway. Omega-3 is a wonderful antidote,
mm.
but it's not enough to just take an antidote. You want to reduce your sugar intake and carb intake as another direct way of trying to help as well.
And you also mention in your letter alcohol, red meats, and salt. But first,
Yes,
alcohol. Does alcohol actually stimulate a production of fructose?
it does. And we have a very large grant from the National Institute of Health because if we block fructose metabolism, we block alcohol craving and we block alcohol liver disease.
Hmm.
And, we put in a patent on it too, by the way. But others have actually shown this as well. And right now we actually have a paper under review at a very top journal where we block fructose pathways as a mechanism to reduce alcohol craving.
Hmm.
And it's not published yet, but yes, it's very real. The way it works is when you take alcohol, it raises the osmolality of the blood and in the liver. This is the number of molecules basically, and what that does is that triggers fructose formation. It activates the production of fructose from glucose. So alcohol itself does not get converted to fructose. Alcohol activates the enzyme that converts glucose to fructose. So if you take alcohol, for example, and you take it with carbs, like you go to a bar and you drink a glass of wine and then eat some pretzels, those pretzels, the alcohol helps those pretzels be converted into fructose in your body, even though that may just be glucose and starch. It will help convert it to fructose in the body, and the salt also helps trigger that conversion. And and so like a lot of times alcoholic drinks or alcohol is given with sugar. You get a drink, Manhattan or margarita or something where they add sugar with the alcohol, and that is a double whammy. And in fact, we've shown in animals that the liver disease is much more quickly induced if you combine alcohol and sugar together. And the effects on the brain will be the same. It's going to be it's sort of depressing if you like a glass of wine every now and then to know that alcohol can actually can generate fructose in the brain. But
And what about red meat? You mentioned that.
yes. So the way fructose works is it generates uric acid in the cell, and the uric acid actually recruits an enzyme to the mitochondria that creates oxidative stress and stuns the mitochondria. So the uric acid is actually involved. Red meats are one major mechanism for generating uric acid. It's more powerful than other types of meats, and it's particularly ultra processed red meats that are particularly bad. And so we think it's actually through that mechanism. And we had a paper in Nature Metabolism that showed that that uric acid can actually activate this pathway as well. And what we found is that it actually stimulates the production of fructose. But in order to produce fructose, you have to have a lot of carbs present. So the red meats would be a main risk factor, especially in the setting of a high carb diet. It would be a little bit less of a risk in a low carb diet.
So you've really found a mechanism that explains the fundamental shift that's occurred in our 21st century diet, which coincides with the development of many diseases, including dementia, Alzheimer's, of high sugar, high refined carbohydrates, high ultra-processed foods, lots of salt, probably too much meat and processed meat, and alcohol. And this is a fundamental underlying mechanism. Is that right?
That's right.
Yeah. And does the Lancet Commission address any of this?
I don't think it does. I'm so sorry to say.
Yeah. So really, it misses the point.
Yeah.
And of course, there are certain things in this report like air pollution, early education, traumatic brain injury. I mean, these are not necessarily easy things to change, especially if you already have them. But here we're looking at something you can fundamentally change, which is what you put in your mouth, its effects on fructose and fructose metabolism, omegas, B vitamins, and so on. This is like a direct effect.
I agree with you.
And of course,
interestingly, a number of B vitamins also benefit this pathway, as does vitamin C. So we've actually proven that vitamin C is a little beneficial in this pathway. But we also have found B1 or thiamine is beneficial in this pathway. And I suspect that, all these vitamins are beneficial indirectly or directly in this pathway, just as they are very important in pathways that you've described.
Now, one of the problems in this kind of prevention research is, number one, you need to identify how many people have the problem. And in this case, let's call it a high fructose, high sugar, high refined carbohydrate diet. And I think the answer there would be, the majority, whatever the number may be, 50, 60, 70, 80%. The next issue is, if you change this, to what extent does it reverse or reduce the risk for dementia? And I would imagine at this point, the problem is that there isn't really the clinical evidence yet to show that.
I can give you I can give you a lot of indirect clinical evidence.
Yeah.
So, for example, studies have shown that people who take uric acid lowering drugs like allopurinol or febuxostat routinely have a lower prevalence of dementia than those who don't take. And so there's some evidence that from epidemiology studies like that, there's evidence that some groups of people who do not have a high carb diet with sugars, and especially kind of have more of a native diet, like the Samani peoples of Brazil, have a very low frequency of dementia. It's known that centenarians have low uric acid as one of their main characteristics that identify that's associated with living longer and healthier. And I think that there's actually a lot of indirect evidence, like in animals, for example. If you put animals on a high carb diet, you can see the development of obesity in a fruit fly. If you give a fruit fly sugar, refined sugar, the fruit fly becomes obese, diabetic, and dies young from kidney problems. It's equivalent of a kidney. Anyway, I think that if you knock out this enzyme, animals live longer. This enzyme involved in fructose metabolism, they are protected from some of the changes with aging. I think it's pretty clear to me that we could do, that it's not an on-off thing. It's really a spectrum, right? So people who eat a huge amount of sugar and are generating a lot of fructose are one end of the spectrum. So, as many as 25% of adolescents, in adolescents and young adults, the diet of the amount of sugar that's that they're eating can be as high as 20 to 25% of all the calories they eat, whereas in other people it's like 10% or 15% of their diet.
So one of the issues is, if you're going to look at, if you like, corrective diets, what's the yardstick? Because you've got, you can have percentage of carbs, you could have glycemic load, which is both to do with the quantity of carbohydrates and their glycemic index. I mean, until we have researchers sort of, dietary interventions vary massively. So we need a sort of a criteria. Right. I mean, I've gone for glycemic load. I know it's not perfect, because fructose is one sugar that has a slightly lower glycemic index, but we're learning that it is worse in many respects. But at least it's a measure, so we could look at those on a high glycemic load or high carbohydrate intake versus low glycemic load or low carbohydrate intake.
Yeah, I think that you're right on the money there. I think that in general, like a Mediterranean diet or like a lower carb diet, definitely trying to reduce refined carbohydrates and try to eat less of these high glycemic foods, and cut out, try to reduce your sugar intake, sweets, don't drink soft drinks, There's a lot of things we can do that could be beneficial.
But we do need to get a bit.
Natural fruits are okay because the fruits contain vitamin C, they contain flavonols and epicatechin and all these different
fiber.
And all these things are good. So when a person eats a natural fruit, maybe they're eating 5 or 10 grams of fructose max, but they're getting a lot of really good things. And we actually did clinical trials where we looked at this, and natural fruits are good. Now, if you're going to drink fruit juice concentrated, where you concentrate 3 or 4 fruit into one glass, then you are getting a high sugar intake. We've shown that apple juice, for example, can activate the switch that I've been talking about. And so that makes fructose, and that activates the survival pathway.
So eat your fruits, don't drink it.
That's the message. Yes, eat your fruit, and if fruit's not bad, it's good. Okay. But if you eat a ton of fruit, you're going to get into trouble. And the other thing that's really interesting is the fructose is what affects the energy levels. So that the fructose is really at the heart of what we think is involved with Alzheimer's. So reducing carbs will reduce fructose, because you either eat the fructose, which is a carb, or you make the fructose from a carb. So reducing carbs will help, particularly high glycemic carbs: bread, rice, potatoes, cereal. Those are the bad guys, and sugar. Those are the bad guys. The rest of the vegetables and carbohydrates are good, right? They're not going to make very much fructose, but the big bad guys. And like when you add salt to like a potato, that makes it more likely to convert to fructose, because the salt activates the enzyme that converts the starch to fructose. So that's why a French fry is really bad, because the French fry, or the chip, or whatever you call it in England, when you add the salt converts the starch, activates the enzyme to convert the starch to fructose. And then you coat it with fat. And then when you're in the activating this thing makes you hungry, but then when you eat a lot of fat, then you'll gain a lot of weight, because you've lost your ability to regulate your weight. So that's why the things like a French fry is bad, even though it doesn't have sugar in it.
No, it's really interesting, because it just sort of shows the perfect storm that we've created with our diet on our brain and our body. My last question is, in studies where we can look at the amount of carbohydrates, the glycemic load, and so on, what's the best measure or measures to go for? Because in a lot of studies, and of course, when people are suspected of possibly heading towards diabetes, they're going to measure the hemoglobin A1C, the glycosylated hemoglobin. We'd love to measure insulin resistance, but it's not so easy and not often done. Blood glucose itself, it varies depending on whether you've eaten or not. So if we are looking at studies that look at the dietary criteria in relation to carbs or GL and some measure, what measure do we want to look for? In other words, if a diet lowers such and such a measure, is it on the right track?
Yeah, so I guess one very big area is to try to keep that blood glucose under control. So some people carry or have what we call continuous glucose monitors, where they can see how their glucose responds to food. And you'd want to keep that on the lower end, If your blood glucose is high, you're going to be converting some of that to fructose. And that's one of the reasons why diabetes is, one of the problems of diabetes is that when your blood glucose goes up, it converts, the glucose gets converted to fructose. But the actual insulin resistance is also driven by fructose. So fasting insulin levels, hemoglobin A1C, they're all things to try to keep under control to reduce your risk. Another very interesting one is hydration. We actually showed that hydration can be beneficial. It can turn off this pathway. And that's because when you're making fat, one of the reasons to make fat is because it not only provides energy when there's no food around, but it provides water. And so there are a lot of animals that will actually stimulate fat or accumulate fat as a means to protect them during dehydration, and this is true like for lemurs during the dry season and orangutans during the dry season, and there's camels and whales don't drink fresh water. They drink fresh water, not salt water. So the fat can be a source for metabolic water, and keeping well hydrated can turn off that pathway to accumulate fat. So drinking 8 glasses of water a day is actually a wonderful move. And if you're thirsty, drink water to control the thirst, and try not to eat a lot of salt, because the salt can help convert the carbs to fructose. So you may need salt if you're sweating and exercising, and salt can be a very good thing, but drink water with it so that you don't get thirsty, because when you're thirsty, that's actually plays a role in activating those enzymes to make fructose. So stay well hydrated, avoid soft drinks, cut back on potatoes, rice, cereal, and bread. Try to eat healthy vegetables and healthy foods. Natural fruits are good, but avoid fruit juice. These are some of the key things you can do to help yourself. And
Rick, that's fantastic. You've given us so many actual practical things to do, but I am reminded just in the close of Marcel Proust, who said the real act of discovery is not in finding new lands, but in seeing through new eyes. And I think that's really the fundamental point here, is you've discovered a mechanism that ties everything together, that hinges entirely on why our modern day diet is driving diseases, including dementia. And, thanks for giving me a new pair of glasses.
Thank you, Patrick. I have written a book on this, actually. It's called Nature Wants Us to Be Fat. And you can also probably just look at some YouTube videos and so forth that I've had over the years related to this. And certainly I have, if you're a scientist or interested, you can go to the medical literature as well.
Thank you so much. That was very enlightening.
Thank you, Patrick.
So we've covered 3 major drivers of dementia. 1, omega-3s, falsely represented by only referring to one of several major trials. Another, homocysteine, rated in other reviews as one of the major evidence-based risk factors, so easily eliminated with inexpensive B vitamins. And the last, the obvious impact of the Western diet, which anyone with half a brain knows is the elephant in the room, driving obesity, heart disease, diabetes, and also dementia. All three basically ignored. What is the consequence of these glaring oversights? That downplay the preventable portion of dementia to only 45%, when in reality it is more likely to be 80 to 90%. I will predict that nothing much will change. Doctors already give statins to lower cholesterol, hypertensive drugs, drugs for diabetes, none of which seem to be working particularly well, and this report only encourages them to still do so. GPs already give people who need them hearing aids, cataract surgery. Perhaps the emphasis on this will mean a few more people will get help with vision and hearing. Governments take no meaningful action to drive down alcohol consumption. Smoking has been more successful, and as a consequence, fewer smoke over 65, perhaps 6%. So this has become a minor contributor to dementia overall. Encouraging exercise is hardly high on the agenda. So our so-called healthcare systems will continue to ignore the true drivers of disease, continue to fail enacting anything that really looks like prevention, continue to not ask about what is really driving disease, which is what we eat and how we live. So I think we have to conclude that it is up to each of us to find our own way, take our own actions and steps towards dementia-proofing diet and lifestyle. The ones we've spoken about in this podcast are so easy. Test your homocysteine and omega-3 index. If not good, take simple actions, eating seafood, supplementing omega-3 fish oils, and homocysteine-lowering B vitamins, eating less carbs, sugar, refined, and ultra-processed foods. That is why foodforthebrain.org exists, and I'm encouraged that every day 100 people are taking the cognitive function test and completing the questionnaire to determine both their future dementia risk index and what is driving that risk. And several thousand have tested their blood levels of homocysteine and omega-3 and taken action to optimize it. It really is not difficult to prevent dementia. But the sad reality is that the establishment do not seem to be looking intelligently and completely at the science and encouraging and empowering people, including their doctors, to take the actions that will make all the difference between losing your mind and keeping your marbles.